Linear equations are fundamental algebraic equations that involve variables raised to the power of 1. They represent straight lines when graphed on a coordinate plane. A linear equation can be written in the form y equals mx plus b. In this equation, y represents the dependent variable, x represents the independent variable, m represents the slope of the line, and b represents the y-intercept, the point where the line crosses the y-axis. Here's a breakdown of the key components of a linear equation. Slope. The slope of a line determines its steepness and direction. It represents the rate of change between the vertical, y-axis, and horizontal, x-axis, coordinates. The slope is often denoted by m and can be positive, negative, 0, or undefined. A positive slope, m greater than 0, indicates that the line rises from left to right. A negative slope, m less than 0, indicates that the line falls from left to right. A zero slope, m equals 0, indicates a horizontal line. An undefined slope occurs when the line is vertical, which means the x-coordinate remains constant regardless of the change in the y-coordinate. Y-intercept. The y-intercept is the point where the line intersects the y-axis. It is the value of y when x is 0. The y-intercept is denoted by the constant b in the equation y equals mx plus b. Understanding the slope-intercept form, y equals mx plus b, helps analyze and graph linear equations. Here's a step-by-step process for graphing a linear equation. Identify the slope and the y-intercept from the given equation. Plot the y-intercept on the coordinate plane. This will be a point with coordinates 0, b. Use the slope to find additional points. The slope indicates the change in y divided by the change in x. For example, if the slope is 2/3, move 2 units up and 3 units to the right from the y-intercept to locate another point. Connect the plotted points to form a straight line. Ensure that the line extends beyond the plotted points to represent the entire line. Solving linear equations involves finding values of the variables that make the equation true. This can be done by isolating the variable on one side of the equation. Various techniques like substitution, elimination, or graphing can be used to solve systems of linear equations. Linear equations are used to model and solve real-world problems involving rates of change, proportions, and relationships between variables. They are an essential concept in algebra and provide a foundation for more advanced mathematical concepts.